As we consider ecological impacts of our modern diets, we need to think about the impacts on our microbial ecology, which is vital to all aspects of our health. So I'm so delighted that our next two speakers are from Finland, will be addressing this. First, I'm thrilled to introduce Erika Isolauri, who's been at the forefront of this work for decades. She was one of the first to examine immune, metabolic and neurobehavioral effects of probiotics in early life, and she's going to talk about the implication of modern diets and ultra-processed environments in general on these aspects of health. And I first came across Erika's work when I was finishing my own PhD a long time ago. So it's so wonderful to see you again after so many years. Welcome, Erika.
Thank you very much. And being pediatrician, my research is focused on early life events, searching for risk exposures affecting the child's later health. So this means the first 1,000 days from pregnancy throughout infancy, which represents a critical period for the child's health. During these stages of development, environmental exposures are relatively limited, but nutrition is a fundamental factor of interaction, a true communicator between our internal and external environment. The modern child faces many challenges. Firstly, progressive increases in the prevalence of non-communicable diseases, such as allergic and chronic inflammatory diseases, neuropsychiatric conditions, and obesity. So while allergic diseases comprise the most common immunoinflammatory disease in childhood, obesity is the most prevalent nutritional disorder throughout the world. So as we heard from previous speaker, we are moving from quantitative malnutrition to qualitative malnutrition. Further, being overweight or obese has a clear intergenerational aspect. Obesity is the most common medical condition in women at reproductive age. Approximately half of pregnant women are overweight or obese. Maternal obesity is associated with high birth weight and increased risk of childhood obesity, while obesity in children is likely to persist into adulthood, carrying the risk of other non-communicable diseases. So this is a true vicious circle of obesity. The gut microbiota is recognized as having a fundamental role in this process. Further, concerning the compositional development of the microbiome, it is of note that almost half of neonates, so the newborns in the first days of life, are exposed to antibiotics. So we ask the question that could promoting healthy host microbe interaction provide a solution to reduce the risk of non-communicable diseases? So this gives one idea how microbiota and non-communicable disease risk interaction works. An aberrant gut microbiota impacts on energy efficiency, and dysbiosis induces immune and metabolic disturbances, both locally and due to the ensuing impaired gut barrier function, also systemic low-grade inflammation, which is causally linked to consequences also outside the gastrointestinal tract, metabolism and our behavior. And Sam will talk after me about these examples more accurately. Thus, to take this evidence together, unhealthy food not only directly affects our health, but also indirectly by modifying the gut microbiota composition, which in turn influences nutritional accessibility to the host and therefore further boosts weight gain, and also affects the intestinal homeostasis and provokes pro-inflammatory tone in the GI tract, but also beyond. Next slide. So, but also the nutritional surroundings are also important, and the whole food chain. We know that if you look at the panel, the table to the left, we know that environmental biodiversity is declining rapidly and at alarming rate. And so is our contact to environmental biodiversity due to antibiotics, changes in hygiene, diet, and lifestyle. So the Living Planet Index on the left is a measure of the state of the world's biological diversity. We see a decline during the past 50 years. We recently studied how it looks from the point of view of our internal environment. We showed that the distinct gut microbiota profiles in pregnant women from 1997, 2007, and 2017 in the two right panels. The women pregnant in 1997 exhibited significantly higher microbiota richness and diversity as compared to pregnant women in 2007 and 2017. These data provide direct evidence for a decline in our gut microbiota diversity over 2 decades in the same geographical area and population, and a direct parallel to the decline in biodiversity within our natural surroundings. It furthermore appears that the gut microbiota of pregnant women has changed over time to a composition typical for overweight individuals. So the environmental exposures of the child during the critical period of maturation are relatively limited. Birth, home environment, and nutrition. All these exposures from the external environment impact the internal environment, our gut microecology. And importantly, not only the nutritional value of food, but also its packaging, the whole food chain, the way our food is prepared and served. And then we see the environmental consequences of these new practices from the past decades. One solution in my research has focused on specific probiotics. These are defined as live microorganisms when administered in adequate amounts confer a health benefit on the host. The mechanisms are not limited to the microbiota effects, meaning the profile that a specific profile of microbiota is beneficial and the other is harmful. But also there are important metabolic effects and immunomodulatory effects. We start to understand how about these mechanisms. So the probiotics affect provide key contribution to the health by mechanisms including affecting enteral antigens, enhancing digestive efficacy, antigen exclusion, and strengthening the gut barrier functions. Thank you, Susan. Thank you all.